Hey guys, so section 2 here is the area of regular polygons. Like I said in class, this is the hardest section of the entire course. So I've only got 15 minutes to get this this video done, so you'll probably need to stop me, slow me down so you can take notes and things like that, because I have to move pretty quickly. Okay, so we're going to start with the area of an equilateral triangle. This one is not so bad, so this only works for equilateral triangles. Right? We can simplify our equation, our area equation, to look like this, where A is the area, and we've only got one variable in here, S, and S is the side length. So that makes it nice and easy for us. If you have an equilateral triangle, remember all the sides and angles have to be equal, because it's equilateral. All you have to do is find one of these side lengths, square it, put a root 3 behind it, and divide by 4, and you'll get your answer. So for example, if these side lengths are 6, okay, if there was 6, then the area of this would be 6 squared is 36, root 3 over 4. Just simplify the 36 over 4 to 9, and the answer is 9 root 3. Okay? Very simple for equilateral triangles. Now we're going to expand that to all regular polygons. Right? It's not so simple for the rest of them. Right? Got to go through a couple of terms that are going to help us to define what the area of the regular triangle of a regular polygon is. My example, I'm going to use a pentagon, but this works for all of them. So remember that I'm not going to put all the slashes on there, but remember all the sides and angles are the same. Alright, so we're going to start with this regular polygon, and we're going to circumscribe a circle around the regular polygon. Look how good that circle is. Not that good, but it's not bad. So we've got a circle circumscribed around it, and that's going to help us define some of the important terms. Okay, so with that circle, the center of that circle is also the center of the polygon. Right, and from that center, we can draw a radius. Right, so a radius of the polygon is also going to be a radius of that circle, but most of the radii that you could draw in that circle aren't going to be helpful for that polygon. It's only going to be the ones that touch a vertex. Okay, so for example, that radius is going to be really important. Always goes from the center to a vertex. Okay, but you can draw 5 radii that are helpful in this polygon. Alright, the next one is a central angle. The central angle is created from 2 adjacent radii. Okay, so that right there is a central angle. And the way we find a central angle is from this equation right here. It's 360 divided by n. And it makes sense if you draw this out, okay, draw all the radii and all of the central angles. Alright, you can see that when you draw all these, right, we've got 1, 2, 3, 4, 5 congruent triangles. Right? We've got 5 congruent triangles, which makes sense because we've got 5 sides of a pentagon, which also means we've got 5 congruent central angles. Right? So that gives us our n, why that's there. Now why is it 360? Well, because these central angles are just creating one revolution, or one circle, which we know is 360 degrees makes one circle, or one revolution. Right? Now the last thing that we need in order to solve this is the apothem of the apothem. Okay? So this is the perpendicular distance from the center to one of the sides. Okay, what it's going to do is it's going to cut one of those congruent triangles in half, and it's going to give us the height of that triangle. So basically what we're going to do in order to solve for these is we're cutting all these up into congruent triangles, finding the area of one triangle, and then multiplying it by the number of triangles that we've got. That's pretty much what's happening here. Okay, so yeah, this is the theorem. The theorem is 1/2 ANS. Okay, so let me define these for you. Right, where we've got A is area, the little a is the apothem, right, N is the number of sides, and S is the length of a side. Okay, so remember that I said that you're basically finding the area of one triangle and then multiplying it by the number of little triangles that you have. Okay, well that makes sense. Remember, the area of a triangle is base times height. Well, the base of this is your S, the height of this is your apothem, multiply it by 1/2, and the number of sides tells us the number of triangles that we're creating. So that's really all you're doing. It's going to be difficult to find all those sides though. So let's go right into it. Alright, so we'll start with a very simple one, right? The area of an equilateral triangle, so we're just going to use that equilateral triangle formula. Okay, remember that's a equals s squared root 3 over 4. Okay, and I tell you that s is 10, so very simple substitution for us. Put that in for s, so 10 squared is 100 root 3 divided by 4. You can still reduce the 100 over 4 to 25, so the answer is 25 root 3. Okay, now for number 2, we're going to find the area of a square with radius 6. Okay, so if we draw the square, draw the radius. Remember, radius goes from center to a vertex. That's 6. All right, we need to still find some stuff. And we've got 1/2 a and s. All right, we know the number of sides already is 4. We know the number of sides is 4. We don't know the apothem yet, and we don't know the side length yet. So we have to find those things. Well, let's draw them. All right, the apothem goes just like this. Okay, remember it creates a right angle, so we've got a right triangle right there. Well, that's really helpful to us, but we need to find out what the angles of that right triangle is. So that's where the central angle comes in handy. Okay, so remember that the central angle is the angle that's created between two radii, and it's 360 divided by n. Well, how many sides are on this polygon? 4 of them. So to find this central angle, we did 360 divided by 4, which is 90 degrees. Okay, so we know that angle right there is 90 degrees. But we don't want that angle. We want to know what half that angle is, because the apothem here cuts that angle in half. So we want to know what 90 divided by 2 is. Well, it's 45. Alright, so with that 45 degree angle, now we see that this right triangle right here, remember this is our 6. Alright, we've got a right angle there. We got 45 there, which means this is also 45. Well, luckily back in chapter 9, we learned how to solve 45, 45, 90 triangles. Okay, so if you look back at those notes, I'm not going to be able to go over it again, but you divide this hypotenuse by root 2 to get those sides, and so the answer is 3 root 2. So that tells us that the apothem is 3 root 2. Okay, now this 3 root 2 goes right here, and that's half the side length, right? Halfway across the side. So if I just multiply that by 2, that'll give me the side length. 6 root 2. Right, now all you gotta do is multiply all this in your calculator. Okay, the way that I think of it is, I see root 2 times root 2, well that's 2. Okay, root 2 times root 2 is 2, so that cancels out with the 1/2, right? Because 2 times 1/2 is just 1. So now all I've got is 3 times 4 times 6, which is 72. Okay, next level of difficulty, working with a hexagon. Alright, hexagons are lucky because they always turn out to 30, 60, 90 triangles, but I will show you how that happens here in this example. Alright, so we've got to find the area of the hexagon with the apothem 6. So they already give us the apothem, that's nice. We know that's 6. Alright, so when we go to our area equation, 1/2 a and s, we already have 2 of the things. So we already have the a is 6, and the n is also 6, right? The number of sides in a hexagon is 6. We need to find the side length. How do we find the side length? Well, let's draw the radius to create a right triangle. Then we need to find the central angle. Remember that central angles are found, right? This big angle here is 360 divided by n. Well, the number of sides is 6, so 360 divided by 6 is 60. Right, but we don't want the whole central angle, we just want half of it because the apothem cuts it in half. So we're looking at this right triangle here. We see that the 6 is there. That's the right angle. Right, this angle up top is half of 60, so 30. And right there is 60. Right, so we have to solve the right triangle. In order to solve this, we have to divide by root 3 to get our short side, so it's 2 root 3. And multiply that by 2 to get the radius, 4 root 3. Oop, root 3. Okay, now 2 root 3 goes right here, okay? But we don't want 2 root 3, we want the whole side length. So that's half the side length. So that means in order to get the whole side length, you gotta multiply that by 2, which is 4 root 3. Okay, now you can just multiply straight across. What I usually do is, so as to not use my calculator, is to just cancel out the 1/2 with an even number, so take half of it. So I'm going to take half of this 6 and make it 3. That way I can just multiply straight across. 3 times 6 is 18. 18 times 4 is 72. So a equals 72 root 3. That's the final answer. Now these last two are a little bit more difficult because you have to use trig. You don't get lucky 45, 45, 90 or 30, 60, 90 triangles. Okay, so with an octagon, okay, we know octagons look like stop signs. It looks like that. We've got a radius of 4. Okay, so that we got that radius. Now, in order to solve for a right triangle, hopefully you're recognizing a pattern. Well, let's write out what we've got so far. So A and S, we have the A. We don't have A yet. We don't have S yet. All we have is that the number of sides is 8. Okay, but we can solve this right triangle. So you might be able to just recognize that when you create your right triangle with your apothem, okay, what you're going to do is in order to find this top angle, you're going to take 360 divided by n divided by 2. Okay, in order, because you're finding the central angle and then cutting in half. So 360 divided by 8 is 45, divide that by 2 is 22.5. So let's draw that big right triangle to solve. Now this is 4. All right, this is 22.5 degrees. All right, we need to find the apothem, and we need to find this side. Okay, because if we find this side, we could just double it to find the side length. All right, so now you have to use trig. Now with this, hopefully you recognize we're going to use this angle. Okay, we're going to use that angle, so we need to label these sides based on that angle. We know the hypotenuse is always across from the right angle. The opposite is not touching the angle, and the adjacent is the last one that's next to it. Okay, so we can set up some trig equations that'll be helpful to us. If we find the sine of 22.5, that's equal to x opposite over 4 hypotenuse. So is SOH. Sine is opposite over hypotenuse. So we can multiply that out. 4 times sine 22.5, and you get 1.53. Okay, so x equals 1.53. All right, but 1.53 doesn't help us. What we need to do is multiply that by 2, because that only gives us half the side length. All right, so when you multiply that by 2, you get 3.06, which is fine for 3.1. Okay, now we could do the same thing for the apothem, but we need to find the cosine, because ca is CAH, cosine is adjacent over hypotenuse, so A over 4. So you can multiply by 4 cosine 22.5, and A comes out to 3.695 or 3.7. Okay, so we have 3.7. Now you multiply all this out times 8 times 0.5, and you get your answer of area equals 45.3. And you're done. Okay, the very last problem here is the area of a regular nonagon. Same type of deal. Okay, 1/2 A times n times s. We already know the side length. Okay, that's nice. We don't know the apothem yet, but we know that the number of sides is 9. Okay, so if you draw this, okay, you don't even have to draw it. Let me show you a short way to do this. We know that all we have to do is find basically this right triangle, because all we need is the apothem, right? Well, a couple things you can learn from this. If you have the side length as 6, then you know this bottom side is half of 6, which is 3, right? And all we have to do is find this angle, which we know is 360 divided by n, which is 9, divided by 2, which is 20. So that's 20 degrees. So we can immediately set this up with a tangent function. Oh, I need more space than that. Okay, because we know that the tangent of 20, right, we've got the opposite here, and that's the adjacent. Okay, so that's why we can use tangent. So tangent of 20 equals 3 over a. Alright, so we need to multiply by a and divide back by tangent of 20. So a is going to equal 3 over tangent of 20. And when you do that division, you're going to get that the apothem is 8.24. Alright, we can multiply all this out. Multiply by 9, multiply by 6, multiply by 0.5. And the answer is 22.5. Oh, 222.5. That makes much more sense. 222.5. That is all.